Today starts Chapter 4, which is Graphing Trigonometric Functions. To start us off, I want to first let you know that for all assessments with this unit, you will not be allowed to use a graphing calculator since this whole unit is based on graphing. You will, however, be allowed to use a for-function or a non-graphing calculator if you choose to do so. You will have to bring one yourself though, so if you have just a basic calculator, feel free to start practicing on that instead of the graphing calculator. For all of your graphs, we will have our x-axis and our y-axis. So if we have a trig graph, it will always look like something along the lines of f of x equals the sine of x, the tangent of x, the cosine of x. What is your x? Well, that is known as your input, and it will always represent the angle measure. So we always are inputting angles into these equations. When we solve the sine of x, we're solving the sine of 30 degrees, the cosine of pi over 2, or whatever it may be. So our y-axis is all of our outputs. What do we get out of this equation? So that represents the actual trig value, the trig value of that expression. So to start us off, we're going to discover what the sine of x actually looks like in terms of a graph. Now you should know the following values, so go ahead and take out a unit circle, whether it's the one on the back of your booklet or just one of those big unit circles from the beginning of the year. Take that out and go ahead and fill in the following chart. So if I look at my unit circle, when x is 0, or 0 radians, the sine of x, the sine of 0, that y coordinate, is just 0. When I move up to pi over 6, the sine of pi over 6 is just 1/2. Again, we're looking at the y coordinates here. The sine of pi over 4 is root 2 over 2. Now for graphing purposes, I want to approximate that. If you plug it into your calculator, it's about 0.71. Then the sine of pi over 3 is root 3 over 2. Approximate that value, it's about 0.87. The sine of pi over 2, well, that's just 1. Continue into the second quadrant. The sine of 2 pi over 3 is root 3 over 2, which again is about 0.87. The sine of 3 pi over 4 is root 2 over 2. It's approximately 0.71. The sine of 5 pi over 6 is 1/2. And the sine of pi is just 0. Moving on to quadrant 3, the sine of 7 pi over 6 is negative 1/2. The sine of 5 pi over 4 is negative root 2 over 2, which is about negative 0.71. The sine of 4 pi over 3 is negative root 3 over 2, which is about negative 0.87. The sine of 3 pi over 2 is negative 1. And into our very last fourth quadrant, the sine of 5 pi over 3, the y coordinate at that angle, 5 pi over 3 is a negative root 3 over 2, which is about negative 0.87. The sine of 7 pi over 4 is negative root 2 over 2, which is approximately negative 0.71. The sine of 11 pi over 6 is negative 1/2. And lastly, the sine of 2 pi, well, we're back to the start of our circle, which is just 0. Now that we have our xy table filled in for our function f of x equaling the sine of x, let's go ahead and graph the following values. So go ahead and look at the graph we've got at the bottom here, and it's already mapped out, divided into 4 sections on the x-axis. The largest x value or input that we put into our equation was 2 pi, so I'm going to put a 2 pi at the end. If I cut that in half, my middle tick mark would then just be a pi. Cut that in half again, I get pi over 2. And in between pi and 2 pi, well, that's 1.5 pi, but I never represent the x-axis in terms of decimals, so I want to write that as that fraction of 3 pi over 2. Then let's look at our y-axis. The highest y value we ever got out for a sine of x is 1, and the smallest y value is a negative 1. Now this makes sense for what we know about the function sine of x. Your values, whenever I plug in an angle, for the sine of some angle, you will never get a value that goes past 1 or past negative 1. So I always get those values that are in between negative 1 and 1. ahead and start plotting these values of my graph sine of x. Starting at, I'm going to divide up my x-axis a little bit more, so half of pi over 2 is just pi over 4, and then throw in those two values, pi over 6 and pi over 3. It's a little crammed, you have to estimate slightly. And let's start with 0. When my input was 0, I got out a y value. My sine of 0 is just 0. The sine of pi over 6 is 1/2. So at pi over 6, I'm up at 1/2. The sine of pi over 4 was that root 2 over 2, which we approximated to 0.71. So kind of guesstimate where that would be located. And then the sine of pi over 3 is 0.87. Almost up to 1. We don't officially reach 1 until the sine of pi over 2, and then my value is at 1. Continue in this fashion. Go ahead and finish off your graph. And pause your video because I'm going to finish mine as well, and then when you start it once again, you will see a completed graph. So as you can see, I've continued this pattern of plotting my x and y values, and you should have sort of a pattern of dots that looks similar to mine. I want you to go ahead and connect those dots, and you should end up with a graph that looks like a wave. It should appear very curved, especially at our top and bottom. This should not be a point. It should be very much an arc shape. And that's the graph of a basic sine of x. Before we fill in the left-hand side that has all of our values, I'm going to switch to the next slide, which has all of the definitions that appear on page 2 for your notes. So if you need to double check your graph and copy any of those points down, why don't you go ahead and pause the video. In the meantime, I'm going to go ahead and switch to my next page, which has a lot of definitions. So I'm going to talk through these real quick, and then I'll give you a chance to write them down by pausing the video. To start us off, we have the domain. The domain is what angles we can put into our function. What are all of those possible x values, my inputs? The next vocab word is range. This is what values will come out of my function. What are all of the possible values that I can get out? What are those trig values? Those are represented by my y values. Next is the period. This is the length of the wave before it starts to repeat itself. How long does this graph last until it starts to repeat? Next is the amplitude. This is the distance from the middle of my wave up to the highest point or down to the lowest point, and it's going to be the same whether I'm measuring to the highest or to the lowest. Lastly is your critical values. These are the important points that we want to graph on our pictures. For any trig function, you always need to plot 5 points to help you graph accurately. So I know we just graphed a ton of points on that sine of x graph. That was just to discover how it actually appeared to be, but you won't actually graph that many every single time. You're only going to have to graph 5, and I'll show you those in just a minute. So pause the video so you can write down all of these vocab words, and then when you're ready to start up, please press play. So now that we know that those new vocab words, let's go ahead and label those on our picture. The first that I want to talk about is the period of this wave, and that was represented by the part of my graph before it starts to repeat itself. So one thing to note is that your sine graph will continue in the same fashion. So I know it's going to go off and start to go up again in a wave, and then over here it's going to come down and continue in that wave fashion once again, because our circle repeats itself. So I can continue to plug in different angles and get those same values out. So this is considered one period of my graph. One period where it's been I've completed one full wave. It's gone up and then back down. That is considered one period. How long did that last? Well, that was a distance of just 2 pi. Next is our amplitude. This is defined as the distance from the middle of my wave up until the highest point, or from the middle of my wave down to the lowest point of my graph. Well, based on my y values, this is just a distance of 1. The amplitude is 1, it's a positive 1. It will always be a positive number. So since we're referring to distance. And next we have domain. This is what values was I able to plug into this function. Well, I can plug in any angle and get some output. So my domain is just all real numbers. If you prefer to write that as negative infinity to positive infinity with brackets, that's totally fine. Lastly was our range. What values do we get out of our function? Well, the lowest we ever went was a -1, and the highest value that I ever got out was a +1. Now I need to put brackets on both those values because I am including them. At 1, my y value from when I actually do get a value out. When the sine, or when my angle is pi/2, the sine of pi/2 gives me 1. The sine of 3 pi/2 gives me a -1. And the last thing that I want to talk about are your critical values. The 5 basic points that you're going to plot for a sine of x graph is going to be 0, 0. And one thing to know is that sine will always start at the 0, 0 for just a basic sine graph. Then pi/2, +1, pi, 0, 3 pi/2, -1, and 2 pi, 0. Those are my 5 critical points that you have to plot whenever you graph a sine of x picture.